Heyo! It's Mr. Schultz here, live from Lake LBJ. Or at least in my mind, I'm live. By now, you can probably tell this is virtual background. But anyways, I'm here to bring you Unit 5, Day 3 of Geometry. So, what's Unit 5, Day 3? Special right triangles. So it's like the Pythagorean theorem, but special. We have special relationships that help us solve these triangles in no time flat. So let me share my screen with y'all, and we'll just jump right into it. So there's two types of special right triangles. The first kind that we're going to look at is called a 45 degree, 90-degree triangle. This is, like I said, one type of special right triangle. Why do we call them special right triangles? Because they're a right triangle that's special. You can use a square and the Pythagorean theorem to find the relationship among the side lengths of a 45, 45, 90. So notice here that I'm not really writing the degree sign because, fine, I'll put it in there. But we don't say, when we talk about these, and like you'll hear me say in class, I'm not going to say, or I'll say in class, in the notes, I won't say 45 degree, 90 degree. I'm just going to call it a 45, 45, 90 triangle and be done with it. I'm going to leave the word degree totally out. But anyways, let's use a square in the Pythagorean theorem and try to figure out what relationship could they possibly have. By now we know the Pythagorean theorem, hopefully. We've spent 2 days on it. So what I want us to do is use this triangle that I just put in green, and let's find y. But I don't want to find just y in any way. I want to find it by simplifying the radical. And let's see if we notice something when we do this. So let's see. Y is going to be which side of mine? Y is my C. So that means that's A, that's B. So here I'm going to have 6 squared plus 6 squared equals y squared. Well, 6 squared is 36 plus 36 equals y squared. That's going to give us 72 equals y squared. Now, like I said here, we want to, when we take the square root, we want to simplify the radical. I don't want it as a decimal right now. That won't do us any good. So let's see, I'm going to go with 2 and 36. And then split 36 up to 6 and 6. Now, like I've said since day one, couples go out on a date, singles stay home. So these 6's would come out, and we could say that y is equal to 6 square roots of 2. Oh, I think I see a pattern. I think I see a pattern here. Look what has popped up now 3 different times. Not 1, not 2, but 3 different times now. I've got a 6 here. I've got a 6 here. And my longest side has a 6. And then what do I have here? The square root of 2. Very, very interesting. Let's see if that always happens. Well, according to this theorem, it does. Because if you look down here, these were 6s in our example. And then what was this x? A 6. So you're in a 45, 45, 90 triangle. Both legs are x. And the length of the hypotenuse is the length of the leg. Which remember, the length of the leg here is x times the square root of 2. So our legs are x, our hypotenuse is x square roots of 2. That will always be the case for a 45, 45, 90 triangle. Always, every time. That's what makes these special right triangles, because the sides have a special relationship. So I'm going to try to leave this theorem up here so we can see it, because we'll need to reference it. I do want to erase these 6s though, because they don't go with the theorem. Okay, so let's do some examples so we can get some practice using this. And to do this, what I want us to do is label our hypotenuse as such and the legs. That way we know. Okay, so our hypotenuse has to be x square roots of 2. The side across from the right angle has to be x square roots of 2. Because that's what this tells us up here. So I'm going to erase that. The side across from the right angle must be x square roots of 2. The other two sides are x. So what does x equal here? Well, let's see. This side is 7. This side is also x. So that means x equals 7. So our side over here is 7. Our side up here is 7 square roots of 2. That's literally all we had to do here. Like, no math. No math. Wow. Okay, let's try that again. So here are my 45-degree angles right here. That side's going to be x square roots of 2 because it's across from the right angle. We have x and we have x. So what's x equal to here? It's equal to 10 square roots of 2. So that means this top side is going to be just 10 square roots of 2 because that's what x is. We're done with that top side. Down here, I'm going to have to do 10 square roots of 2 times the square root of 2. Remember, this is our x. This whole thing here is our x. And then we just bring down our square root of 2. Well, what does this equal? 10 square roots of 2 times the square root of 2. That's like saying 10 times 2, which is just 20. So this side is 20. So we have 10 square roots of 2 and 20. Those are our two sides that are missing. Whew. Okay, now for the next one. To the next, to the next, to the next. We need to find our big side first. I want that to always be your first step. Label your big side. There's our big side. It's x square roots of 2. That's what that's equal to. That side's just x. That side's just x. Well, here we have a little equation we've got to solve to get x. We've got to solve this equation here. So let's do that. I want x by itself, so I'm going to divide by the square root of 2. Now notice, they want our answers in simplest radical form. So don't just put this in your calculator and say, oh, bleh, here's your answer. It's, I don't know what it is, but it's some decimal. No, don't do that. X is equal to 16 times the square root of, divided by the square root of 2. But I can't leave it like that. Remember on day 1, I said this was bad juju. We've got to multiply by our special number 1 here. So we're going to get 16 square roots of 2 divided by 2, which can be reduced to 8 square roots of 2. This is our x. So this side is 8 square roots of 2. Done. This side is 8 square roots of 2. Done. So this is the easy one. The 45, 45, 90 is your easier one. But at the beginning of today, I said there's 2 kinds. You have the 45, 45, 90 that we just looked at. Then we have one called the 30, 60, 90. That's the next one we're going to look at. So a 30-degree, 60-degree, 90-degree triangle is another special right triangle. And to illustrate its relationship, we're going to use an equilateral triangle. And they want us to find the value of y using our old school Pythagorean theorem. So y is this side right here. Well, let's see. That's a right angle because it tells us it's an altitude. So that means this is our C. That 5 is our A. That's our B. So I'm going to have 5 squared plus y squared equals 10 squared. 5 squared is 25 plus y squared equals 10 squared is 100. Subtract 25. we get y squared equals 75. Square root it. Again, I want to simplify my radical. I don't want decimals. Nothing you do today should really have decimals. There's only, I think, one possible question. Let me double check. Yeah, there's one question that may have decimals, and that's only because they gave you a decimal. Two, take that back, two possible questions. But again, they gave you a decimal. Otherwise, no. Okay, so we need to simplify this. That's going to be 75. Let's see. 75 is 3 times 25. I break 25 down to 5 and 5. And then let's see. Couples go out on a date. The single stays home. So he comes out here. The single stays home. So y is equal to 5 square roots of 3. Now, that's kind of odd, isn't it? What do you notice here? What do we notice here? This side is 5 square roots of 3. This side is 5. This side is 10, but what's 10 equal to? 2 times 5. Got a 5 there. Got a 5 there. And I've got a 5 there. So if I think back to my other relationship where I used x, what do you think this one could possibly be? If that side's x, the bottom's x, what could this one be? X square roots of 3. And the hypotenuse, because our right angle is right here, 2x. There's our relationship on a 30, 60, 90 right triangle. But let's formalize that on the back of the notes. So in a 30, 60, 90 triangle, the length of the hypotenuse, so remember the hypotenuse is our longest side, is 2 times the length of the short leg. So the length of our short leg here is x. And the length of the longer leg is the length of the shorter leg. So remember, our shorter leg is x times the square root of 3. So on these, the short leg is x. The long leg is x square roots of 3. And the hypotenuse is 2x. Those are the only sides that we need to calculate, possibly. If we know the short leg, we can easily get the others. If we know one of the others, we can easily get, so if we know one and we know it's 30, 60, 90, we can easily get the other. So let's look at this example. So this side here is my hypotenuse. It's going to be my 2x. This is my short side, so it's just x. This is my long side, not long leg, so it's x square roots of 3. How could I possibly find x? Well, the key here is this. What does 2x have to equal? 16. So if I divide by 2, I'm going to get x equals 8. Oh, okay. So if x is 8, that means this side is equal to 8. And this side equals 8 square roots of 3. I just plugged x in. That's it. Okay, let's look at the next one. There's my hypotenuse. What does my hypotenuse always have to be? 2x. Here's my 30-degree angle. So this is my short side over here on the left. It has to be x. And my long leg has to be x square roots of 3. The long leg is x square roots of 3, which, hey, what's that mean? That's got to equal 12. So let's divide by the square root of 3, because I want to get x first. So x equals 12 divided by the square root of 3. Can I leave it like this? No, the square root of 3 is on the bottom. So multiply by your special number 1. So it's going to be 12 square roots of 3 over 3. 12 divided by 3 is 4 square roots of 3. That's my x. So that's what goes over here, 4 square roots of 3. Because that's what x is. Now, let's look at this long side. I have 2 times x. So 2 times 4 square roots of 3. What's 2 times 4? 8. And then my square root of 3 just tags along. There's that side, and I'm done. And the last one. So I've got my 60-degree angle. That means this one has to be 30 degrees. And also, there's my right angle, so this is going to be 2x down here. My short leg is always x. My long leg is always x square roots of 3. If we have a 30, 60, 90. So now, what's that mean? That means x equals 9. So anywhere I see an x, I want to plug a 9 in. So 9 square roots of 3 equals 2 times 9 for that side. This 9 square roots of 3, that's all I can do. So he's done. What about 2 times 9? What's 2 times 9 equal to? 18. So I'm done. Special right triangles, it takes a little bit to get the hang of it. But if you label your sides like we started every time, label your sides. I'll put it down here in red. Step 1, label your sides. Step 2, find X. And step 3, use X to find all sides. That's really all there is to this. Label the sides. So you're either going to do 40, based on which one you have, you'll label your sides, then you find X, then you use X to find all sides. That's really all there is to this. So with that being said, we're done with notes. So stay tuned for the guided practice.